This is the last video for Unit 0. This is Lesson 4. Again, remember guys that this is more of an introductory. None of this stuff is absolutely essential to understanding the AP Chemistry exam. However, again, knowing this will just make things a little bit easier for you. So, the last thing we're going to talk about nomenclature, and nomenclature is just about naming compounds, about if I give you the name, how to write the chemical formula. If I give you the chemical formula, how to write the name. Just a couple things before we get started on that. Notice that if when a symbol for an element is a two-letter symbol, notice that that second letter is always written as a lowercase. So in this case, capital C lowercase o is the element cobalt. Capital C capital O is actually carbon monoxide. Okay, so not a big deal. They're not going to mark you off for that on the test. Just know that that is how it should be. Okay, so when we talk about nomenclature, we're going to talk about three different types of compounds. Again, hopefully this is a review. We're going to talk about ionic compounds, which are typically between a metal and one or maybe more nonmetal. We're going to talk about covalent compounds. Many times we also call those molecular compounds, or simply just molecules, and those are between all non-metals. And then we're also going to talk about acids. Okay, and acids, what you need to know for right now with acids is that if something starts with an H, unless it's water, don't do it with water. If it starts with an H and then something after it, it's an acid, unless it's H2O. That is not an acid, it's water. Okay, so when we talk about ionic compounds, we're going to start with this one right here. We're going to talk about, first of all, we're going to talk about binary ionic compounds. Okay, now remember guys that I know this could be somewhat challenging, not going to be any specific questions on the AP test about it, but of course they're going to use chemical compounds. Of course they're going to use names. So the better you know this, the better you're going to be at it. Remember that you have the answer sheet for this, the assignment that goes along with this. So really use those to help. If you're having a hard time understanding this part, look at the questions and look at the answers, and then see if that helps you understand it as well. Okay. So back to ionic compounds, and we're going to talk about binary ionic compounds. Binary ionic compounds are between only two elements. Okay, one of those is a metal, one of those is a nonmetal. Okay, so you've got one metal and one nonmetal. And when you form an ionic compound, think about that term ionic. It has the word ion in it. Okay. So an ionic compound is basically composed of two different ions, a positive ion and a negative ion. So we could call that a cation and an anion. Okay, so in this case, we're going to be dealing with what are called monoatomic. Mono means one, so that means one atom ions. So it's an ion like Cl minus. See how that's made up of one atom? Not like SO4 2 minus. That's made up of two different elements. Okay, those are called polyatomic ions. That's a polyatomic ion there. Okay, and we'll be discussing that here on the next page. Okay, so to find the formula of an ionic compound, you simply have to balance the charges. Okay, and what that means is it means that if you have Na plus and you have Cl minus, that means sodium loses one electron, chlorine gains one, and so basically what you have to do is you have to cancel out the charges. So it's NaCl. Okay, what if you have magnesium that has a +2 charge? Let's go back to the periodic table here for just a minute and make sure we understand this. For right now, where am I getting these charges from? I'm getting them from the periodic table. Okay, if it's right here, it's +1. If it's right here, it's +2. And if it's right here above boron, it's +3. And then over here on the right hand side, if it's above fluorine, it's -1. And you should do this on your own periodic table or even just on your notes. Oxygen's -2 and nitrogen. So everything down from fluorine, everything down from oxygen, everything down has that same charge. So for example, magnesium is right in here. It has a charge of +2. Chlorine's right in here. It has a charge of -1. Okay, and the real easy way to do this, guys, is whatever those charges are, you just switch them, just flip-flop them. So that means that is MgCl2. Okay, what if you have something like Al with a positive 3 charge and oxygen with a minus 2 charge? What do? You again switch them. So aluminum oxide is Al2O3. Okay, and then when you name them, you heard me just do it. You just put the name of the metal, you put the name of the nonmetal, and you change the end to IDE. So aluminum oxide here, magnesium chloride here, and sodium chloride here. Okay, now with the other type of ionic compounds are called ternary ionic compounds. And ternary ionic compounds are ones that do have polyatomic ions in there. And I do tell you they do need to be memorized. Again, you don't have to know anything. However, you want to do well on the AP test. The better you know these polyatomic ions, the easier things are going to be for you. So, for example, acetate, very commonly used on the AP test. Okay, that's when I would definitely, if you're like, well, I can't remember all these. Come on, Johnson. Well, how about we shorten it down here? Instead of 12, I'm going to give you 5 that you're like, come on, you absolutely have to know these. See, now I'm having to choose. Like those 3 for sure. Oh, hydroxide's pretty important. And let's say carbonate. Okay, but really you should know all of them. But again, those are kind of I would say the big 5 ones there. And not a huge deal. Very similar to what we did before. Okay, if you have, for example, and you can see it right here, if you have sodium that has a +1 charge, and it's sodium sulfate, as you can see here, well, sulfate, as you can see, is right here. It's SO4 2-. So it's SO4 2-. So what do you do with those charges? Whoop, down here. And then the 1, when it's a 1, you don't have to write it. So you can see that formula is Na2SO4. So the process is the same. Take the charges up in the corner and then switch them. Okay? And then in terms of naming them, and naming them is even easier. Okay? Before we had to change that ending to IDE. Now you don't. Okay? If you have KClO3, you go, oh, well, K is potassium. And ClO3 is, there it is right there, chlorate. So that is just called potassium chlorate. Okay, the only time that gets a little bit confusing is when you're dealing with the transition metals. So coming back up here, notice that I put a +1, a +2, a +3, but then I left out a big portion of the periodic table. Basically anything from here, and there's a stair step going right here. It's much prettier than the way I've drawn it, but there's that stair step. Anything that's in here is going to have, it can have a variable charge with a few exceptions. Okay, and what that means is it means that, for example, iron is kind of right in here if you look at the periodic table, Fe. Okay, and iron sometimes has a +2 charge, sometimes it has a +3 charge. Well, how are we supposed to know that? Well, you look at the chemical formula. You look at Fe2S3, or you look at FeS. And you go, oh, well, what's the charge on sulfur? Well, that's where you come back up here and you go, oh, well, sulfur is right below oxygen right here, so it's -2. So if sulfur's -2, the iron has to, remember, they have to cancel each other out. So the iron has to be +2. So you write that as iron, and then you do a Roman numeral 2, and sulfur becomes sulfide because that is a binary ionic compound. Okay, down here though, this one's a little bit trickier. Again, we've still got iron and we're still going to have sulfide, but now the question is, what's the charge on the iron? Well, just like before, you can kind of take that charge and, like we did before, move it back up there. Sulfur's -2, and therefore iron is +3. Another way to think about that is sulfur is -2, and there's 3 of them, so that's -6 all total. So to cancel that, the iron has to be +6. positive 6, negative 6, 0. And 6 divided by 2, because there's 2 of them, is going to give you a charge of 3. Okay, and then we have acids. Acids, similar to ionic compounds, is you can have binary acids, and a binary acid is something that contains just hydrogen and one other element, such as H2S or HF or HCl or H3P. All of those are binary acids. Now notice that these two only have one hydrogen. This one has 2, this one has 3. Okay, and obviously the question comes up as to why. Because acids, like ionic compounds, the charges have to cancel. So find phosphorus on the periodic table. It does have a -3 charge, and that tells you how many hydrogens to have. Chlorine and fluorine are both -1s, so that means you only have one hydrogen, and sulfur has a -2 charge, so you have to have the 2 hydrogens. Okay, and then how do you say the name of them? You simply write the word hydro at the front, and then you change the name of this to IC at the end, and then you put acid. So this one here is called hydrosulfuric acid. This one here is called hydrofluoric acid. This is hydrochloric acid, and this is hydrophosphoric acid. Again, just be familiar with those, so when you see those, you have to use those. You're like, what the heck is this hydro thing? You know that if it's a binary acid, it has to have hydro in the front. Okay, the reason that's important is because oxyacids do not have hydro in the front. They're the same way, okay, but you don't put hydro in the front. So for example here, H2SO4 is SO4, as we saw above, is sulfate, and sulfate becomes sulfuric acid. Notice it's not hydrosulfuric acid, that's this one up here. Okay, H2SO4 is just sulfuric acid. HClO3. ClO3 is chlorate, so that becomes chloric acid. Okay, and H3PO4, again, like before. Why is it H3? Oh man, that's terrible, sorry. H3PO4 is because phosphate has, if you look up above, has a -3 charge. So we have to have 3 hydrogens to cancel that out. Okay, and phosphate becomes phosphoric acid. Okay, now again, I know that I raced through this really, really quickly, and you're like, wow, I'm really confused. If it was really important, I would spend 5 days on this, but it's not, and I don't want to waste your time. So this is just a general overview here, and if you get it, great. It's not the end of the world, though. You can easily score very well. You could get a 5 on the AP test and not know how to name things very well, which is kind of sad, but okay. And then our last one here is covalent compounds. Covalent, sometimes we call them molecular compounds, are just nonmetals. Okay, now when you do this, you do have to use prefixes. Okay, and a prefix is something that we use to help us figure out. Okay, so here are the prefixes right here, and we're just going to go up to 6. So mono, di, tri, tetra, penta, and hexa represent 1 through 6. Okay, so when you write that chemical name, or the chemical name, you notice that it's SO2, and we write that as sulfur, and then we put dioxide. Okay, we put dioxide because there's 2 oxygens. Okay, and I know I said, wait, mono you said was 1, but you didn't put monosulfur. Okay, notice that the prefix mono is only applied to the second element. Okay, if it's the first element, if there's 1 of the first element, then you don't put it at all. Like this is a good example of this. CO, we talked about this one earlier. Okay, there's 1 carbon, but it's the first element, so we don't put mono. So we're just going to put carbon. But now the second element, there is only 1 of them, so that is monoxide. And notice there would be that double O there, so you just take that out. Okay, water is a very common one as well. Water obviously on the AP test they're going to call it water, but just for fun, technically the name of water would be dihydrogen, because there's two hydrogens, monoxide, because there's one oxygen at the end. So the chemical name of water technically would be dihydrogen monoxide. Okay, last couple things here. There are 7 molecular compounds that occur naturally in nature as what are called diatomic molecules, which means whenever they're by themselves, they're not actually by themselves. There is always 2 of them. Remember, di means 2, so diatomic means 2 atoms. So oxygen is never O. If it is, it will react with whatever it hits first. We'll talk about that later, why. Okay, but oxygen will always react. So when it exists in nature, the oxygen we breathe is not O, it's O2. Okay? Now, the 7 elements are these 7 right here. Whenever I always kind of use this term Brinkelhoff to kind of cram them all together, you do need to know that. You definitely need to know that when those elements are by themselves, if they say fluorine gas, you don't write F, you write F2. If they talk about chlorine gas is Cl2, iodine is I2, and all 7 of these, there's always 2 of them whenever they're referring to just that specific element. Okay? Okay, and then the very last thing here is what are called hydrates. Hydrates are when water is attached to certain, usually ionic compounds. Okay, and they're, again, pretty rare that you're going to see this, but let's just make sure we know it. So CuSO4, Cu is copper, and SO4 is sulfate. Okay, but copper is a transition metal. Remember, it's in that middle section, so it needs a Roman numeral. Okay, and it has a 2 because sulfate has a charge of its SO4 2-. So that's copper 2 sulfate. And then notice at the very end of there, anytime it's a hydrate, they use those same prefixes from before. So the prefix for 5 is penta. So then you see that penta, and then we just throw that hydrate on the end there. Okay, and going back here just real quickly to that periodic table that we were looking at. Okay, as I said, remember in this middle section here, anything from this line over to the stair step that goes down over here, any of those will have to have a charge with them. Oops, I erased the whole thing. Okay, and what that means is it can have a charge that can change. Okay, and so what we want to make sure we understand here is my drawing ability is terrible. Okay, is that when you're in this region down here that goes to the stair step all the way down, all of those elements can have varying charges with 3 exceptions. And it's nice because they go in a nice diagonal row. Okay, they are aluminum up here, zinc, which is diagonally to the left, and then silver. Okay, aluminum is always +3. See how it's in the +3 column? Okay, everything else below aluminum, though, can change its charge. So don't think that, oh, it's that whole column. No, it's just aluminum. Okay, zinc is always +2, which is right there. And then silver, which is, again, diagonally, is always +1. So it goes +3, +2, +1. Okay, and so overall, any other element in this middle section, with the exception of those 3, must have a Roman numeral when you write the name. If it's one of those 3, you don't. Okay, and that is the end of Unit 0.